Hello class, I'm going to go ahead and talk about 5.2 exponential functions and graphs. So you should kind of on your notes do it similar to like in class, take the notes, copy the problems, and then that should make your homework go a little bit smoother. But I'm going to go ahead and jump into it, and we're going to start with talking about exponential functions and graphs, which has the form f of x equals a to the x. A being your base, and x being your exponent. Okay, and the first examples want us to graph a few of these exponential functions. So how do you graph anything? Plug in some points. So I'm going to kind of stick with my go-to points here, and we're just going to plug them in. So 2 to the negative 2, 2 to the negative 1, 2 to the 0, 2 to the 1, 2 to the 2. Then I'll evaluate them backwards kind of. 2 squared is 4. 2 to the first is 2. You know what 2 to the 0 is. Anything to the 0 power is always 1. 2 to a negative exponent, if you recall, I'm going to write it up here, is 1 over that x to the positive of that exponent. So this is actually 1 over 2 to the first power. 2 to the negative 2 is actually 1 over 2 squared, which is 1/4. So this is enough to graph it. And I'm going to graph negative 2, 1/4 is approximately here. Negative 1/2 is a little bit higher. 0, 1 would be here. 1, 2 is here, and 2, 4 would be approximately here. So I can start to see the shape of this line, and I'm going to fill this in. Now, if I think about this, so this is what an exponential growth looks like. But if I think about this, if I kept putting numbers less than here, ask yourself this question: is it ever going to get below the x-axis? You know, like 10 to the or 2 to the negative 10. Well, no, it's just going to keep getting closer and closer to 0. So in fact, on these graphs, the exponential functions, we have a horizontal asymptote at y equals 0. Okay, for anything of this format. Okay. So that's 2 to the x. Okay, well, what about half to the x? Let's try that. We're going to do kind of the same thing, but let's do the same points, 0, 1, 2, and we're going to plug them into this equation. 1/2 to the negative 2, 1/2 to the negative 1, 1/2 to the 0 power, 1/2 to the 1 power, 1/2 squared. Okay, so I'm going to start at the bottom again. I'm going to do 1/2 times 1/2. That's 1/4. 1/2 to the first is 1/2. 1/2 to the 0 is 1. And 1/2 to the negative 1, that ends up being the reciprocal. So that's 2. And 1/2 to the negative 2, that ends up being the reciprocal, which is 2 squared, which that'd be 4. Okay, so similar numbers. So let's graph this and see what this looks like. Okay, so negative 2, 4. So this time it starts up here. Negative 1, 2 goes down. 0, 1, and 1, 1/2, and finally 2, 1/4. So you get this kind of graph going down. Okay, and again, you'll see this. There's this horizontal asymptote here at y equals 0 again. So those are those two graphs. We're going to do similar things with the other two graphs. Okay, so again, we'll make a table. It's not much different. This is probably the part of the class where I'd say, okay, you try this. So I don't know, maybe you can pause the video and try it yourself before you see me do it. So this is 3 to the negative 2, 3 to the negative 1, 3 to the 0, 3 to the 1, 3 squared, 3 times 3 is 9, 3 to the first is 3, 3 to the 0 is 1, 3 to the negative 1 is 1/3, 3 to the negative 2 is 1 over 9. Okay. So we can graph from there and just go to -2, 1/9. We're going to see it's very similar. 1/9 would be very close to 0. And -1, 1/3 would be a little bit higher. 0, 1, 1, 3. So now you'll notice it does rise a little bit quicker. 1, 2, 3, 4. Here I'm going to do 5, 6, 7, 8, 9. Okay. Yeah, I know, a little unorthodox here, but just to kind of get the point in, this will go through here, through here, through here, and then rise up to that. Okay, so this one you'll see rises a little bit faster than y equals 2 to the x. Just a thing to note, but we've graphed it. Okay, and also, same thing, has a horizontal asymptote at y equals 0. Okay, so let's look at 1/3 x. We'll do kind of a similar deal. -2, -1, 0, 1, 2. Just plug it in. 1/3 to the -2, 1/3 to -1, 1/3 to the 0, 1/3 to the 1, and 1/3 squared. Okay, and evaluate. So 1/3 times 1/3 is 1/9. 1/3 to the first is 1/3. 1/3 to the 0 is 1. 1/3 to the -1 turns out to be the reciprocal, so that's just 3. 1/3 of the -2 is 3 squared, so that's just 9. So now I can graph it. Okay, so -2. Let me change my scale here a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9. -2, 9. -1, 3. 0, 1. 1, 1/3, and then 2, 1, 9. Okay, so I have this graph. Now, some questions in the same asymptote. Okay, so here's some follow-up questions with these that we can notice now that we have all 4 of these. What do we notice about the graphs, or what makes the graphs rise or fall, do you think? Well, this is a 2 to the x, this is a 3 to the x, and both of these are rising, right, or increasing, we call them. And here on half to the x power, that's decreasing, and 1/3 x power is decreasing. So what is it about the base that makes it rise or fall? Well, 2 and 3 are both numbers greater than 1, and half and a third are both numbers less than 1. So maybe a side note would be if a is greater than 1, then f of x is increasing. Okay, and then if a is less than 1, f of x is decreasing, which you can write in there. Okay, so those would be 2 good things to note. Also, just real quick on all of these, what's the domain? Well, x could be any number, so it's -infinity to infinity. In other words, all real numbers. The range for all of these in particular, well, the lowest y that you can get to is at the asymptote. So the range would be 0 to the highest would all be infinity. Okay. Okay. So that's all I want to say about those 4 that we all have. Now that we have them all up on the board, so let's move on to graphing something like this. F of x equals 2 to the x minus 2. Kind of looks like 2 to the x, except you add the extra 2, the minus 2 at the end of the exponent. So I probably wouldn't use my trusty numbers here. I'm going to think about what makes this exponent 0, and that's going to be my middle number. which what makes it 0 is 2. So 2 is my middle number, and I'm going to pick two numbers before that, 1 and 0, and two numbers after that. And that's what I'm going to plug in, okay? So let's see. We're going to get 2 to the 0 minus 2, 2 to the 1 minus 2, 2 to the 2 minus 2, 2 to the 3 minus 2, and 2 to the 4 minus 2. This is 2 to the negative 2, this is 2 to the negative 1, this is 2 to the 0, this is 2 to the 1, 2 to the second, which should look familiar. That's 4, that's 2, that's 1, 2 to the 0 is 1, 2 to the negative 1 is 1/2, 2 to the negative 2 is 1/4. Okay, so now we can graph it, okay? So do that. Let's say 0. I'm gonna put some lines over here. Okay, so 0, 1/4 is about here. 1, 1/2 is a little bit higher. 2, 1 is here. 3, 2 is here, and then 4, 4 is here. Okay, so there it is. Now you'll notice that as compared with 2 to the x, what does it do? Well, that minus 2 actually turned into a translation to the right 2 units, okay? In fact, you can kind of note that in the table. These coordinates just shifted right 2 units, right? So instead of starting at -2, now I start at 0, but you got the same outputs. But all that means is from 2 to x, it's a horizontal shift of 2 units to the right, okay? Okay, so now on to the back side of 5.2 notes, which starts with graphing, a little more graphing. So here I'm going to kind of use my go-to points for x, which we would say -2, -1, 0, 1, and 2. Just plug it in. 5 minus 0.5 is -2. 5 minus 0.5 is -1. 5 minus 0.5 is 0. 5 minus 0.5 is the 1. 5 minus 0.5 is the 2. Well, 0.5 squared is kind of like half squared, so that's 0.25, or half times half is 1/4. But we'll leave it as decimals. Gives you 4.75. 0.5 times 0.5 is 0.25. 5 minus 0.5 is 4.5. 0.5 to the 0 is 1, so 5 minus 1 is 4. This is half. Half to the -1 is 2, so 5 minus 2 is 3. Half to the -2 is 4, so that's 5 minus 4 is 1. Okay, so I have a table of points. That means I can graph. Okay, so we're going to just graph a few of these. And -2, 1, -1, 3, 0, 4, and 2, 1, 4.5, and 2, 4.75. Okay, so we end up with this kind of graph. Now this actually, you'll notice that it's actually never going to pass this. So what did the 5 do that we didn't have before on the other graphs, right? When we had the 2 to the x graph and the 3 to the x, there was no extra number out here. We just kind of had, this was like the half x. What did the negative do to the half x? It reflected it across the x-axis, and what did the 5 do? It shifted up the asymptote and along with all the points by a factor of 5. So you see this kind of has this shape to it now. Okay, similar to our previous graph, half x, right? And then also with the fact that it's shifted up 5 units, so the asymptote was shifted up 5 units. Okay, so so that can happen. You could have reflections across the x-axis, and you can have vertical shifts of whatever unit size. Let's go on to the next question, which says, suppose that 100,000 is invested at 6.5% interest compounded semi-annually. Find a function for the amount after t years. Okay, so you do have a formula for this, which, let me talk about that formula real quick. A equals P times 1 plus R over N to the NT power. Should be there on your notes, but let's talk about each of these variables. A is the amount after t years. P is the principal, meaning that's the initial investment, that's what you put down to begin with. R is your rate, and then I always like to make sure it has a decimal. N is the number of times compounding, and I like to give these notes. So you could have annually, semi-annually, quarterly, monthly, and daily. Okay, so annually is how many times per year? Once. Semi-annually is how many times per year? Twice. Quarterly is how many times per year? Quarters, so it's 4. Monthly, 12. Daily, 365, right? So if a question says compounded annually, semi-annually, quarterly, monthly, daily, these are the values you need to use for your N. Okay, so now to answer this question, it says find a function for the amount after t years. Well, we're going to use the formula. The principal amount in this question is 100,000. So we're going to say A equals to 100,000 using P for principal times 1 plus the rate. What's the rate? 6.5%, but as a decimal, 0.065 over N semi-annually, that's 2. So the power of 2, and that's N times T. T would be the unknown after t years. So we've created an equation of this after t years. Okay, so get a little closer here. Now B says find the amount of money in the account after t equals 0, 4, 8, and 10 years. So quite honestly, on this part, I would probably put this into y equals, and then use your table to get these values. Okay. So we're going to find out A of, here's one notation of this, A of 0, A of 4, A of 8, and A of 10. So that's what I'm going to do. I'm going to type this into the calculator, and I'm going to find these values, okay? Okay, so I did what I said I was going to do, which I typed this into the calculator into y equals, and I just used the table. Found A of 0 is 100,000, which makes sense. After 0 years, you started with 100,000, so you should have 100,000. After 4 years, it grew to 129,000. After 8 years, it grew to about 166,000. After 10 years, it grew to about 189 or 190,000. So then, just using this, we're going to go ahead and graph it and see what that looks like. So make an XY coordinate plane, and I'm going to see my X's are 0, 4, 8, and 10. So I can use these points. I don't have to get any additional points. So 0, 4, 8, and 10. So I'm just going to go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the lowest is 100,000, and the highest is 189,000. So I could make a decision to go by 50,000s. That'd be 50,000, 100,000, 150,000, 200,000. Okay. Go ahead and label it 50,000, 100,000, 200,000. Okay, so this said I can graph this as follows: 0, 100,000, first point, 4, 129,000. My second point would be about here. 8, 166,000. Should be about right here. And then 9, 189,000. I'm sorry, 10. So you can see a slight curve here in the exponential, not linear, definitely not linear, but this is what we call the compound interest function. Okay, so that's enough of that one. I'm going to go ahead and look at the next example, which is kind of another calculator application where you're just going to type it in. Okay, so you might want to try that, see if you get the same thing I get. Okay, so for e to the 3, I typed in a calculator. By the way, the e is slow. You got to push second division on your TI-84 or 83. And then that gives me 20.0855. As it does say to the, I believe to the 4th decimal, e squared, 7.3891. And e to the negative 0.23, 0.7945. And e to the first is 2.718. Now, just a little bit about e. It is one of these numbers that comes up in nature, like pi, for instance. So it's one of these things that does come about. Pretty interesting. Maybe you might want to do a little research on that, but it comes up very often, just like pi does. Okay. Now, what about graphing these? So we're going to graph y equals e to the x and y equals e to the negative x. Okay, so to graph e to the x, we're going to want to make a table -2, -1. Well, actually, no. We're going to do not -2. We can try -1, 0, and 1. Okay, I think 3 points will be enough. We kind of see the general shape of these exponentials. So we're going to do e to the -1, which is 1 over 0.271, or 2.71. E to the 0, which we know is 1, and then e to the 1, which we know or can estimate is 2.71. So let me graph this one first. We're going to do graph here, and -1 will be fairly close to 0. Oh, well, a little closer to half. Okay. And then 0, 1 would be here, and then 1, 2.71 would be about here. There's my exponential. Excuse me. So let me use this space. Let me use this space here. So we're done with the exponential. I'm going to graph this next one here. I'm going to use the same coordinates, 0 and 1, but e to the -1, e to the 0, and e to the negative 1. Well, e to the negative 1 is just e, so that's 2.71. E to 0 is 1. This is 1 over 2.71, which is kind of close to half. So it's going to start here at about negative 1, 2.71, 0, 1, goes to the same point, and it kind of does the reverse of that. But you can kind of expect that because that's a reflection across the y-axis. Okay, so anytime you have f of x and f of negative x, this is kind of like f of negative x of this one, so it's going to be a reflection across the y-axis, and that's exactly what happens. Okay, so for this one, we'll kind of do a similar thing. We're not going to graph too many points or plot too many points, but we'll do like 0, and then I'm gonna pick negative 2, I'll pick 0, and I'm gonna pick 2. Why did I pick negative 2? Because I know negative 2 is going to be negative 2 times 0.5 is 1. Okay, so this is really e to negative 0.5 times negative 2, which is really e to the 1, which I know that's 2.71. Okay, this is just going to be e to the 0, so I know that's 1. This is going to be e to the negative 0.5 times 2. Okay, which I know is e to the negative 1, which is 1 over e. Okay, or 1 over 2.71, pretty much. Okay, so just from that, I can probably graph it. Negative 2, 2.71, it's about here. 0, 1 is here. 2 would be about there, okay? So we got kind of like this horizontal stretch going as compared to what we had up here, right? So this one's kind of stretched out. Okay, so in a similar way, I'm going to pick values here. Okay, so on my last one, we're going to do, I'll pick maybe half. Okay, so then I'm going to pick half, negative half, 0, and half. Because I have e, so I have 1 minus e to the negative 2 times negative half, which is 1 minus e, which is 1 minus 2.71, which is negative 1.71, okay? This would be 1 minus e to the 0, because that would be 0, so that's 1 minus 1, so that's 0. Here it'd be 1 minus negative 2 to the 1/2 power, which would be 1 minus negative e, or 1 minus e to the negative 1, okay? You know what, I might get away with just doing the first 2 points here. Excuse me. So here would be 1/2, or negative half, negative 1.71, about here. So negative half, negative 1.71. And then 0, 0 would be here. Okay, maybe one more point. It's 1 minus 1 over 2.71, which is almost 1/2. So that'll be 1 minus almost 1/2, which is about close to 1/2. Okay, so you kind of get this, and then you have that asymptote at 1 because of that. Yeah, so, okay, there's the final graph. And that'll complete the lesson. All right, so good luck, and I will see you next time.